And BC free response 3. Let f of x equal e to the 2x. Let R be the region in the first quadrant bounded by the graph of f, the coordinate axes, and the vertical line x equals k, where k is greater than 0. The region R is shown in this figure. Again, much better on the real AP than on my crappy drawing, but you'll survive. Part A, write but do not evaluate an expression involving an integral that gives the perimeter of R in terms of k. Okay, so the perimeter of R is going to break down into 4 sections, right? We've got this section. Well, this section goes from 0 to 1, so it's 1 unit long, right? We've got this section on the x-axis that goes from 0 to k, so it's k units long. And we've got this section that goes from 0 to the y-coordinate e to the 2k, so it's e to the 2k long, right? Those are all numbers, right? They don't feel like numbers because of the k, but they're just numbers. So those 3 are really simple sections of the perimeter. The wild card of the perimeter that's going to involve the integral, and the part that makes this a BC question, is that you're going to need arc length to find the blue curve, right? That's a curvy, non-linear side of this shape, so I'm going to need arc length. So my perimeter in part A, right, my perimeter is going to be the 3 red lines that are really easy to add up, 1 plus k plus e to the 2k, right? That's the 3 red pieces. Plus, and now I'm going to need the formula for the arc length of this curve. So as a reminder, when you find arc length, right, so arc length from, let's just say, a to b, for lack of a better way to say it, right, is the integral from a to b of the square root of 1 plus f prime of x quantity squared with respect to x, right? So if I know that's the formula for arc length, that's all I have to write, right? But now I'm integrating from 0 to k, right? And my f prime, right? So I already have f, right? F was e to the 2x. So my f prime is 2e to the 2x. Now, since I don't actually have to integrate this, I'm not going to clean this up. I'm going to leave this as the integral from 0 to k of the square root of 1 plus, in parentheses, 2e to the 2k quantity squared with respect to x. I'm not going to make this a 4e to the 4k. I don't need to. Why would I bother? They just wanted me to write an expression for perimeter, which I did. So here's my perimeter. So again, the 3 nice, easy linear parts, and then this is the arc length for the curvy part. Part B. The region R is rotated about the x-axis to form a solid. Find the volume of the solid in terms of k. Cool. So let's erase this stuff because we don't need it. And cool. All right. So I'm going to see if I can erase this stuff without totally butchering my graph. Okay, cool. So this region, right, this region is rotated about the x-axis. So essentially what it's doing is it's creating a disk of radius little r, where this little r is the top curve, e to the 2x, minus the axis of rotation, which is 0, so my radius is just e to the 2x. The area of this one disk is pi r squared, which is going to be a pi times an e to the 2x quantity squared, right? When you put a power on a power, you multiply them, so this is the area is equal to pi e to the 4x, right? To find the volume, I'm going to add up all the disks. So the one that starts at 0 all the way to the one that ends at k. So I'm going to integrate, right? So what's going to happen, sorry for not making that super clear. So what's going to happen is my volume is going to be the integral from 0 to k of pi e to the 4x with respect to x. I can yank the pi out in front. And then, although this is technically u sub because your u would be a 4x and your du would be a 4dx, that's fine. You can also recognize that if you were to derive e to the 4x, every time you derive, the chain rule would mean that you'd multiply by 4. So if you're integrating e to the 4x, every time you integrate, you're going to divide by 4. So I end up getting this is a pi over 4. And then e to the stuff integrates to e to the stuff, right? Evaluated from 0 to k. So what's going to happen is I'm going to get that this is a pi over 4 times e to the 4k minus e to the 0. So pi over 4 times the quantity e to the 4k minus 1, or you could distribute the pi over 4 if you want. I chose to leave it factored out. It doesn't matter. They're the same answer. So if you wanted to make this a pi over 4 times the e to the 4k minus a pi over 4, that's also right. So if you like this better, that's fine. Right? It kind of just depends on how you dealt with the pi over 4 in the first place, whether you kept it factored out or distributed. Cool. Part C. The volume V found in part B changes as k changes. If k dt equals 1/3, what is dv dt when k equals, so this is volume, right? What is dv dt when k equals 1/2? So this suddenly turned into a related rates problem. So I need my formula from B. That's my equation for my related rates. So remember that when we do related rates, this is part C, we're going to use DREDS, right? Diagram and rates. E is equation, which is the equation I just found. I guess I'll leave my pi over 4 there. I'm cool with it. Minus pi over 4, right? I'm going to derive that equation with respect to time. I'm going to substitute in the specific stuff that I know. And then I'm going to answer the blasted question, right? Because it's actually DREDS SA. So diagram and rates, I don't really need a diagram here, but it would probably be worth listing the stuff that I know, right? What they want in this problem is dv dt, right? And they want it when, and they give me some specific stuff, when dk dt is 1/3 and k is 1/2, right? So let's go ahead and use this information, right? So we're going to go ahead and derive this with respect to time. Well, the derivative of this with respect to time is dv dt, which is the thing I want anyway, equals, when I derive this guy with respect to time, right? When I derive e to the stuff, I'm going to get e to the stuff. So there's this pi over 4 sitting in front times e to the stuff times the derivative of the stuff, which is going to be a 4 dk dt, because I'm deriving something that's not t. I can go ahead and cancel the 4's. So if I clean this up a little bit, I get that dv dt is equal to a pi times an e to the 4k times dk dt. Well, I know all of this stuff, right? What I want is dv dt, but I was asked at the moment when k was 1/2, so that would be pi times e to the 2, because 1/2 times 4, and dk dt was 1/3. So I should get that dv dt in units that they didn't give me, so I can't be asked what they are, should be pi over 3 times e squared. Or any version of that, right? I think they gave their answer as a pi times a 1/3 times an e squared, which is probably the last thing I would have done, but cool, whatever they want to do.